Hello everyone, and welcome to Khan Academy Live SAT class. My name is Eric Lee. I'm an SAT tutor and one of the SAT experts here at Khan Academy. I'm so excited to be joining you today and over the course of the next 3 weeks as we practice and prepare for the SAT. Before we jump into SAT Math, which is the topic for today, I want to give you a sneak peek at what's coming ahead over the course of the next 3 weeks. Let's take a look. So, today, like I said, we'll be covering SAT Math, but next Thursday, I'll walk us through some SAT reading topics, and the following Thursday, we'll cover SAT writing. Now, each of these classes is going to take place Thursday nights at 7 p.m. Eastern, 4 p.m. Pacific, and we're covering a different topic each time, so make sure to tune in. Now, if you can't make any of these classes, don't worry, because we'll record all of the classes and send them out to everyone afterwards so you can review it whenever you want. So I'm super excited to be going through this. And for today, we're going to focus on math, like I mentioned. So what's the plan for the day? Well, the first 25 minutes of today, I'm going to walk through how to avoid careless mistakes in the SAT Math section. Next, I'll show you how to approach function notation problems, which are a common concept tested in the SAT Math section. Then, in the next 25 minutes, you'll get a chance to practice what you've learned on Khan Academy. And while you're practicing, we'll have Khan Academy and College Board staff on standby who can chat with you one-on-one about and answer any question you have about SAT Math, reading, writing, or anything SAT related. You'll want to make sure to practice during this time, though, because these staff members are only going to be on until the end of the hour. Then, in the last 10 minutes of class, I'll answer a few questions, discuss homework and the plan for the next class, and then you'll get your badge for completing the class. But remember, you have to stay to the very end of the class to get that badge. So that's the plan for the next 3 weeks and what we're going to cover today. And I'm so excited to get started with SAT Math and to help you practice and prepare for your upcoming test. Let's jump in. So why are we talking about careless mistakes? Well, let me know if any of these questions sound familiar to you. So have you ever solved for the wrong variable in an SAT Math question? Or maybe you missed a question because your final answer was in the wrong units? Or maybe you were working through a problem and you stopped one step short of the right answer. You were almost there, but not quite. Or maybe you went one step too far. Or maybe you made a simple addition or subtraction error. Or this one is probably the most annoying to me. Maybe you even got the right answer, but then you didn't transfer the right answer to the answer sheet. Well, all of these types of mistakes are perfectly common human mistakes that anyone can make. But what I'm going to show you today is a process that's really helped me and helped other students reduce the number of careless mistakes they make. There are other ways to go about it, but this is one process that's worked really well for me. So let's take a look. So there are really 4 steps that I'd recommend you take to cut down on careless mistakes. So the first one is just to read and understand the question and any charts or tables that you have. Now this is both the question and any charts or tables, so don't move on until you really understand everything. And one thing you can do here is underline as you go sentence by sentence to break down the question rather than trying to take it all in at once. The next thing I'd recommend is that you think through the steps you need to take to solve the problem. So this includes things like figuring out which variable you're solving for, so x or y. This is thinking about what units your final answer needs to be in, and any operations that you need to do to get to the right answer. Once you know what steps you're going to follow, you can then start actually doing the math. And so I would do this on paper or in the calculator, and I'd really discourage you from doing the math in your head, because no matter how confident you might feel about the problem, the moment you're doing you start doing more mental calculations, you really up your chances of making a careless mistake. Now, the last and final step that I'd suggest you take is to mark down the answer in your test booklet before bubbling it in. So say our answer was B64, then I recommend you circle it or you write it and you box it so that when you're transferring answers for this problem to the answer sheet, you have no doubt in the world that your answer is B and the right answer makes it over there. So to recap, you're going to want to read and understand the question and any charts or tables. Think through the steps you need to take to solve the problem. Do the math on paper or in your calculator, and then mark down the answer in your test booklet before bubbling it in. So this is a process that we're going to now apply when it to real SAT math questions. And let's take a look at what this looks like. The first question will be more straightforward, and then we'll see how this applies to more complex questions as we go. So let's take a look at this first question. So first step is to read and understand the problem. So during a time test, Alexander typed 742 words in 14 minutes. Okay, 742 words in 14 minutes, that seems worth underlining. Assuming Alexander works at this rate for the next hour, which of the following best approximates the number of words he would type in that hour? Okay, so I have some information, and for me it's helpful to write down the information I have, since it just helps me better understand it. And so we have 742 words in 14 minutes, and then the question is how many words would Alexander type in 1 hour? So in this case, it's 60 minutes. Okay, so I understand the question and the information that's been given to me. And the next thing I want to do is think through the process I want to follow to solve this question. So I think the first thing I could do is figure out how many words per 1 minute. And then because the question is asking me how many words would he type in 1 hour, the second thing I can do is multiply by 60. So that seems like a good process and will get me all the way to the final answer. So now I can actually start doing the math. So to calculate words per 1 minute, I can just do 742 words divided by 14 minutes. And I'll pull up my calculator. And the real thing, you won't have this digital calculator, you'll have your own, but just bear with me here. And so here I have 53 words, and so that's 53 words per 1 minute. Words per 1 minute. But I'm not done yet, right? So the second step here is to multiply by 60 minutes. And the interesting thing you'll notice here is once I multiply by 60 minutes, I've actually got a minutes factor in the numerator and a minutes in the denominator. And so any unit divided by itself is just going to be 1, so that would go away. And then if I do this math of 53 times 60, let's do that, multiply this by 60, we get the final answer of 3,180, and then last step is to box that answer or write C so that there's no chance of me misbubbling. So the last thing I want to show you here is what the process does in questions like this. So because we knew that we needed to solve first for the words per minute and then multiply by 60, it meant that some of these other answers were less tempting. So while we got 53 words here, and while it was an answer choice, we knew that that wasn't the right final answer because we hadn't taken the second step here of multiplying by 60 minutes to get to the hour. Hopefully this shows you how to apply this process with a question that has a few steps in it and you're dealing with some units. But let's see how this process stacks up when we apply it to a different kind of question, different scenario. So in this next question, let's give it a read. Geometry students participated in an activity to classify the shapes in the room by number of sides and color. Okay, the table above displays the results, and then if a triangle is chosen at random, what is the probability that it is blue? Okay, so we're classifying shapes, and we want to understand the probability that if a triangle is chosen at random, what's the probability that it is blue? So before I move on from here, just because I understand the question, doesn't mean I'm ready to actually start solving it yet, because in this case, we have this table here that we want to tackle first. So let's take a look and make sure we understand the table before we go any further. So we've got shapes on the left-hand side, we've got these colors here of red and blue, and then these total columns. So total, this total column on the right-hand side, it seems to be the number of shapes. And then this one on the bottom, this total column is number of shapes that are by color, and this one is shapes by type, okay? Okay, so now I understand the question, I understand the table, and now I can start to think about how I would solve this. So let's read that question again. If a triangle is chosen at random from this activity, what is the probability that it is blue? So that to me says that I'm going to be focusing here on just the triangles, because it says if a triangle is chosen at random, so I'm not worrying about these quadrilaterals or the pentagons or the others. And then it's asking me, what is the probability that it is blue? Well, I've got the blue triangles here, and so there are 3 blue triangles, and probability is always how many chances of getting something out of the total number of chances, and so that total number of triangles then is here, and you've got 3 out of 4. Now, what I want to point out here is, in this problem, understanding the table was crucial, because you'll notice if you look at some of the other answer choices, the totals that you have in the rest of the table are also present here. And if you didn't take your time to understand the table, it might have been tempting to use some of these other variables that you see in the table, like the 16, the 8, or even this 1 as well. But if you follow an organized process, then that's how you can cut down on these kinds of mistakes. So we've done now a question with units and a few steps in the process. We've done a question now with a chart that you've been presented. Now let's take a look at what happens with a problem that has a few steps in it and you don't have a diagram drawn for you or a chart presented to you this time. Let's take a look. So let's give this problem a read. Kara is hanging a poster that is 91 centimeters wide in her room, okay? The center of the wall is 180 centimeters from the right end of the wall, okay? If Kara hangs the poster so that the center of the poster is located at the center of the wall, how far will the left and right edges of the poster be from the right end of the wall? Okay, so a little bit more information to work with this time, right? But this is where breaking down the problem piece by piece and drawing a diagram as you go can really be helpful. So let's take a read. Kara is hanging a poster. It's 91 centimeters, so I've got my beautiful poster. Excuse my inability to draw straight lines. So this is my poster, and we've got 91 centimeters here. And then I've got a wall that I'm hanging this inside of. So if I draw this wall, and it says the center of the wall is 180 centimeters from the right end of the wall. So then I'm just going to estimate the center's got to be about there. And so if this is the center is 180 centimeters from the right. So we've got 180 centimeters. And then I have this diagram, and now I'm putting the poster so that the center of the poster is located at the center of the wall. So then I'm going to move that poster inside here. And then this again is 91 centimeters. And now, what is the question now? Now I have this diagram that can help me solve the problem. The question is, how far will the left and right edges of the poster be from the right end of the wall? Okay, so I've got this right end of the wall, and I want to know this distance, so the left edge of the poster to the right end of the wall, and then the right edge of the poster to the right end of the wall. And I can label this one L, and then I'll just change colors here. This one I'll label R. So now that I have the diagram, it really helps to clarify what I'm dealing with and what I'm solving for. So let's take these one by one. So if I want to solve for this distance of L from the left edge of the poster to the right wall, it looks like this 180 centimeters here is a pretty good starting point. So it's at least 180 centimeters since I'm all the way to the center. And then I have this half of the poster that is just to the left of the wall. And because I know that this poster is 91 centimeters wide, I can add 91 divided by 2. And so then this should get me the value of L. And so if I do open up this calculator. I've got 180 plus 91 divided by 2. And that'll get me 225.5. 225.5 centimeters. And now I want to go to the right edge. And I think I can use this 180 centimeters again as a reference point since I know that poster is right in the middle, right? So we've got 180 centimeters. And then this time, this half of the poster is actually closer to the right edge of the wall than this one. And so instead of adding something, it looks like we'll have to subtract. And again, since I know that this is 91 centimeters total, I can subtract 91 divided by 2. And then pull up that calculator again. 180 minus 91 divided by 2 gets me 134.5 centimeters. So then I want to look at my answer choices now, and I've got the left edge at 225.5. Okay, well that one's out and that one's out. And then the right edge should be 134.5, and so then my final answer again is C. So in this problem, it was very important to work through the information given to you step by step and to draw a diagram to help you work through it piece by piece, because if you had done the simpler, tried to skip through and do it mentally, you might have done 180 minus 91 or plus 91, and you would have missed some of the nuances in this problem. But once you draw the diagram, it becomes a lot easier to work through. So we've now done a handful of problems to show you how you can use this process to really reduce your chances of making careless mistakes. And now I want to move us on to tackling function notation problems. So let's keep going and let's take a look. So function notation. Before I actually start doing practice problems here, I just want to walk you through a quick review of function notation. So what is a function first? Well, a function is a mathematical expression that takes in one or more inputs and generates only one output. And that's really key, though, having one or more inputs, but all of those only ever generating one unique output is what really sets a function apart. Now, a few ways you might see functions notated in the SAT is with something like f of x, or maybe h of x, or you might see a composition of functions where you have f of h of x, and this is also equivalent to this f of h of x. These two expressions are the same thing, just a different kind of notation. Now, let's say, for example, f of x equals x plus 1. Another way you might see functions show up is in a table format. So in this case, you have this nice table here of f of x and f of x. And for given values of x, given this definition of f of x, you'd have certain values of f of x. So this is one way you might see it. And then the last way you might see a function show up is graphically. So here we have a graph where there's x and there's f of x. And for example, there's 1, 2, 3, and you've got 1, 2, 3. For certain values of x, you might have corresponding values of f of x or y. And so with a chart like this, you can really trace on the x-axis and then go up and see what the corresponding y value or f of x value is at that value of x. So these are really, this really covers a lot of the different ways that function notation can show up in the SAT, but you haven't seen a practice problem yet, and so let's now apply what we've seen here to see it in action. So let's take a look here. Just because we're no longer focusing exclusively on careless mistakes doesn't mean we're changing our process, though. So same process as before. Consider the table shown above. What is the value of f of 4? Okay, so I've got that as the question. And then I have a table here. So for given values of x, then I have corresponding values of f of x. And so we've got f of 4. So when you have a function notation question like this, the key thing to remember is that you want to work from the inside out. Now, what do I mean by that? I mean that the first thing you want to solve for is this f of 4, and then you can worry about the let me just rewrite that. Then you can worry about the f of 4. And so if I solve first for f of 4, it's really asking me what is the value of f of x when x is 4 here. So if I've got, use the table, I've got 4, and the corresponding value of f of x is 0. So then this 0 I can substitute into here, and then this expression simplifies to just f of 0. Then I can return to the table, and for that value when x is 0, f of x is 2. So I've got 2. I box the right answer. I'm realizing now all of the answers to these sample problems seem to be C. Promise that was not on purpose. But let's keep going and see what this looks like when the table's a bit more complicated or there are a few more pieces of information to work with. Okay, consider the table shown at left. What is the value of g of f of -1? Okay, so for me, I prefer to see this as g of f of -1. That's just easier for me to understand, and so it's always okay to rewrite a problem so that it's, or rephrase it so that it's easier for you to understand. So again, this is similar to the last one, and I want to work from inside out. But let me make sure I understand the table first. So this time I've got given values of x here, and then I've got f of x, and then I've got g of x up here. Okay, so I want to solve then inside and then outside. And so f of -1 then, so let's go to the table. When x is -1, what is the value of f of x? So it looks like we're right there. We've got 2, and then we can plug this in similar to the last problem and solve and simplify this to say g of 2. And in this case, we return to the table. We're looking at 2, and then this time I'm looking at g of x, so then I'm looking over here at 4. So this is another example of function notation just with a different way of expressing it. And now we'll do one final function notation problem, this time with a graph. So let's keep moving. So what is the approximate value of g of f of 5? So that one makes sense to me. And then on this left-hand side, I have the graphs of the function of f and function g shown below. So here's f, here's g, and then for certain values of x here, the y values of f and g are shown. And okay, so I think I understand that. Now, again, I want to solve inside out. So f of 5, and then I've got g of f of 5. And what we can do here is we'll now have to reference the chart here. So when x is 5, to solve for f of 5, what is the value of f? So what I can do is trace up through here, and it looks like I'm intersecting f here at 9. And so then the value of f when x is 5 is going to be 9. And I can substitute that into here, and this becomes g of 9. And then I can look at the table here. So when x is 9, here, I can trace up, and this time I'm looking at x. And it looks like I'm intersecting here at 7. So then this value is 7. I mark down 7, and you're good to go. So now you've seen a few ways to reduce the chances of making careless mistakes on the SAT. You've seen a few different flavors of that with a few different problems, and you've also seen a few different examples of function notation problems. So now it was probably easier to follow along as I was working through it, but to see if you've understood it, it's now your turn to practice what you've learned. So head to khanacademy.org/SAT. The link is also in the event description. And head over there and join me as I head over there to practice what you've learned. Now, for the next about 25-30 minutes, Khan Academy and College Board experts are available on standby to chat with you one-on-one, and there will just be a little box in the bottom right of Khan Academy where you can click Ask Us a Question and send us any SAT-related question you have. Then at 6:50 Eastern, 4:50 Pacific, come back here, join me here. I'll wrap up, answer any questions you might have, and then I'll share a badge. I'll share the badge that you earned by completing this class. So head on over. I'll head over there too, and then I'll see you in just a bit.